Hey everybody, welcome back to me learning to program Rust. So far we've done a little bit of work on the Crawford projects. If you've been following along, you know what we're doing is we're just following project one of these little projects to help you learn how to program. And with this one in particular, we're learning how to analyze molecular geometries. So far in the project, everything that I've completed up until this point is I've read a file, and then I have separated each of these individual pieces into their respective vectors. That's what I've done here. The vectors include the charge of the atom, as well as their x, y, and z coordinates, respectively. In the last video, we did some refactoring, and so this is kind of the final product that we had the last time that we left off. And today we're going to be taking a look at some more of these other things, like computing bond lengths, angles, out of plane angles, all of these. We'll see what we get to today, but that's kind of where we're headed. So thanks for tuning in, and hope you continue to follow along. All right, well, I guess I'll just go ahead and hop right into doing a little bit of these bond lengths here. I think we finished everything last time, right? We read the data from each line into appropriate variables, and then it says to close the file, but we don't really. I guess
Rust does that for us.
Oh, thank you.
When the file, so I don't think we've actually talked about this specifically yet.
Yeah.
But Rust has this concept of scope. Actually, most languages have this concept of scope.
Yeah. Mm-hmm.
And that's the region of your program, usually the region of the text, really. Mm-hmm. Especially in a simple program, where a variable is valid.
Mm-hmm.
And the way that Rust manages memory is that when things go out of scope, they're not accessible anymore, so Rust drops them. So there's a trait called drop and a function called drop, and that actually basically frees the memory.
Okay.
So that's what happens with files. You use the file, when the file goes out of scope, it gets dropped and closed.
Right. Cool.
Pretty handy.
I remember the last time we were working on these for a class, we were doing Go, and didn't we have to like tell it to close?
Yes.
Or like we would have to, I can't remember what it was called, but like we would open it and then we would immediately say, once we're finished with this, close it. That way we didn't forget to close it. Yeah.
Yeah, in Go it's called defer.
Yeah, that's what it is. Defer. Yeah. Defer close or something. Yeah. Okay.
Yeah. Defer file.close, something like that.
Well, I was just before we started recording, I was telling Brent that the last time we did these projects, I could not for the life of me figure out why we were for looping over anything, or why we were even doing this. So to give you a little hint as to where we're going, today we're just going to be essentially practicing our for looping. So the next step in this project, step number 2, is to compute bond lengths. And so you can see with this much better picture, that in order to compute bond lengths, what we want to do is follow this equation here. And so the appropriate thing to do, I guess, is to start looping over x, y, and z coordinates. And so I'm assuming that we can do all of this in the same function, and it's not going to like radically break anything. So I guess we'll start with, I guess we should make a new function, right?
You could, you can if you want.
Okay.
Or you could just start. So this is kind of a refactor as well. But personally, just my taste is to put the main function at the bottom of the file.
Yeah.
And then I put like utilities above it. Like that.
Okay.
That way, when it gets long, you go into the file and you just go to the end.
Yeah.
It's like, oh, here's main.
Right.
Yeah.
Okay. Well, let's see. So function, and then I want to call this, I guess, what's up?
No, go ahead. It's fine.
No.
It's fine. Don't let me, I won't derail you.
Okay. Well, if I'm doing something that's not like normal for a Rust user to do, I want you to tell me.
This is totally fine. It's just, all right, this is like a peek behind the curtain, okay? I don't want you to like change your behavior, but I'm just going to tell you what I'm thinking. Okay. So I kind of think it might be a good time to talk about structs.
Okay.
Because that would be a good way to put all of this data together. So you see, actually, I think if you run Clippy right now, it would complain at you because LoadGeom is returning a complex type.
Okay.
And actually, you can try that. So I really, the first thing I meant for you to do is actually run the code just so we see what comes out.
Oh, okay.
But while you're at it, we can go ahead and run Clippy.
Okay.
Because things are about to get more complicated. So a big thing that comes up a lot in programming is managing complexity.
Oh, no.
So you basically want to make things as easy for yourself as possible.
Yeah.
And so I'm a little suspicious that we're about to start feeling the effects of this complexity.
All right. Whoa, what just happened? There we go. So you wanted me to, what was it, Clippy or run, or just
Well,
run?
yeah, you can just, cargo space Clippy.
Okay. Bro, where's the Y button?
Oh, okay, I guess it's not complicated enough yet to complain.
Oh, perfect. That's what I like to hear.
Yep.
Okay.
All right, well, no problem then.
Okay. Well, I like what you said, so I'm going to do cargo run. That way we can...
Yeah, just see what comes out.
Yeah. All right, perfect. So we get all of our different vectors that we had, and it printed all of those, our charge, X, Y, and Z, and then it just printed the regular file back to us. Just for goodness sake, I guess. Okay, so the learning about structs thing. Yeah. Would you like to elaborate on that?
Actually, I think it would be fine for you to go ahead and define your function, because I think the act of writing out the function signature is going to make my point for me. So let's go for it.
The function signature. What is that?
Yeah.
Is that this thing up here?
Yes.
Okay, perfect. So I mean, I would just call it probably bond length.
Sure.
Like that, and then I'll do this, and then what do I want to return?
Good question.
Yeah. Well, I mean, I want to return the bond lengths.
Yeah.
But
so I think in the project, sorry, I think in the project they actually just print everything. So I agree that you should return them because that'll be nice for testing. So if eventually we want to like test to make sure you're returning the right values,
yeah,
that would be nice. But for now, I think they actually just print them. So if you wanted to just print, you wouldn't have to return anything.
Oh, okay. So if I didn't want to return anything, would I just leave it here? Or would I still need the...
So you can... Okay, yes. To be strict, you would say arrow, and then you would say open and close paren.
Okay.
Because open and close paren, actually just like Lisp, which we have talked... I know I'm not supposed to bring up other languages, but you've been writing Emacs Lisp for your config.
Yeah.
Just like in Emacs Lisp, open and close is like an empty list.
Yeah.
Or in Lisp, it's equivalent to nil.
Okay.
So in Rust, this is called unit.
Okay.
So it's basically just like the empty thing.
Okay, that makes sense.
But Rust also allows you, just like main down below, you can, if you're returning unit, you can omit the arrow and the parens.
Okay.
So you can actually leave that out.
Okay. But so the point you were making though is that for testing purposes, we would want to return something. But we'd want to
but we're not testing yet.
Yeah. But we want to return the value of the bond length, right?
Sure.
Okay. Well, then I guess I'll leave this out then. All right. Well, so I guess the first thing we'd want to do is we want to do a for loop over all the x coordinates, right?
Sure.
So like I would just say, following their example, for, I guess, hold on, I need to do, I'm getting stuck because I thought it would indent for me.
Oh, I think it's because you left out the closing curly brace.
Oh, that makes sense. Okay, all right, that makes sense. So I would do like for I in All right. I see you. I see you smiling over there. I'd like you to explain what you're smiling about, because
No,
I
no,
guess I
no.
should have. I guess I should have looked up how for loops work in Rust.
No, you know how for loop. You're doing it right. I'm smiling because you're just about to realize some things. I hope. And it's right here. Okay, for I in what?
Yeah, that's right. Yeah, that's true. Yeah, that's true. I guess I would want to do for I in the contents of the vector x.
Okay, so there's also actually, this is actually not a computer science thing or programming actually. This is actually about the equation itself.
Yeah.
If you go back to you might want to go back to the project. I mean, it would be really nice if we could see the equation and the project, but it's not a big deal. Okay, so what are we calculating here?
We're calculating the bond lengths.
Yeah, we're calculating the interatomic. Oh yeah, just read this. Calculate the interatomic distances using the expression where x, y, and z are Cartesian coordinates.
Yeah.
You've got that covered. You've got your vectors. But take a look at what I and j are.
Yeah.
I and j denote atomic indices.
Okay. Oh, I see. Okay, so okay, all right, I get. All right.
So you don't actually want to go blasting down your x, y, and z vectors. You actually need some concept of atoms here.
I see. Okay, and this is, I think, where your idea of the struct was starting to come into play.
Yeah, I mean, you can do it again. You can do it without the struct. You can totally do it without the struct, and you can just do it with some slightly complicated indexing techniques. So it's up to you. If you want to, this is it's your choose your own adventure, right? We can back up a little bit and talk about structs.
Yeah.
Or we can do some indexing practice. It's up to you.
Oh God. Well, I feel like the struct would probably make the most sense.
Okay, sure.
I mean, I feel like that would probably make sense, but also I feel like maybe index practice is a good thing for me. But
well, I think we will do a lot of indexing in this in these projects in general.
Yeah.
So it might be a good time to learn about structs.
All right, well that's fine. So let's learn about some structs then.
Okay. So actually, I think it might be good. Do you have the book pulled up still?
This book, or this, or
yeah,
this
that
book?
one, that one.
Okay.
Let's see. Do they have?
Yeah, using structs, defining and initiating.
Let's take a look at that, because they might explain it better than I do.
Oh, look at that.
Let's see. Why don't you? Do you want to read the first paragraph to us? It's like a real class.
Are we gonna popcorn read?
Yeah, popcorn read.
All right. Structs are similar to tuples, discussed in the tuple type, in which in that both hold multiple related values. Like tuples, the pieces of a struct can be different types. Unlike with tuples, in a struct, you'll name each piece of data so it's clear what the values mean. Adding these names means the structs are more flexible than tuples. You don't have to rely on the order of the data to specify or access the values of an instance. Okay. Adding these names means the structs are more flexible. You don't have to rely on the order of the data. Oh, okay, okay.
So actually, we skipped the tuple section of the book, but you've defined a tuple. Remember from last time. If you hop back to your code, so
yeah.
you're returning a tuple from your load geom function.
Yeah.
And I think you can probably kind of get a sense for what they're talking about here. Like all you know when you call this function is that you're getting back a string, a vec usize, a vec f64, vec.
Okay, so what? All right. So if I wanted to do this struct based on how they did it, I would say struct, and then can I just call it atom?
Sure.
Okay. Well, maybe not atom. I don't know. It doesn't matter right now.
It's okay. Names aren't actually important.
Yeah. Oh no. Okay.
And you're getting a blue squiggle because in Rust we make structs with a capital first.
Oh.
But that's again very minor, not important.
Okay. So is this where I would specifically define a name like charge X, Y, and Z, and then what the type is that they are?
Yeah.
Okay. So I do charge.
Can you hear that awful ringing sound from outside my house?
Barely.
Okay. Sorry, YouTube.
So this is a string. is there, do I need to do it? Yeah, okay, so they're comma separated, and then X, which is a, oh wait, hold on. The charge is not a string, the charge is a vec, usize.
Yep.
And I need to do it like this too, where I do.
Yep.
Usize. Okay, perfect. And then this is a vec f64. Vec f64. Yeah. So what is that noise? Who's using their thing?
I guess it's probably a leaf blower.
Yeah, that's what it sounds like.
Either that or somebody's vacuuming their yard. Which sounds hilarious. And my wife and I actually saw a video yesterday of somebody vacuuming their backyard. We were like, what are they doing? They're probably on drugs.
Are they collecting the leaves or something?
No, hold on. And then last night, my dad texted me.
Oh wow.
And he had a shop vac out in our yard. And somebody had backed into one of our trees and their back window exploded. Oh. So he was vacuuming glass out of the yard.
Nice.
So now I don't question anybody vacuuming the grass. There's probably glass out there. I understand.
That's funny. Nice. Okay, so this is,
yeah, there you go.
This is a struct called Atom.
Beautiful.
All right, so now how is this going to change my function load geom? Because I would assume that I would need to put these in its own struct, right? Or I've already defined, I need to put this in something. I guess I should probably read
you defined the struct. Now, you could actually update your return value. So where it says string, vec, you can now say string, comma, atom, and get rid of all the vecs.
Oh, wow. Okay. Because
you're going to pack the vecs inside of a struct.
Okay. Atom like this?
Yep.
Oh, so cool.
Much nicer, right?
Yeah, that is. Yeah, that's a lot nicer. Okay. So, I guess I don't want to jump the gun, but because I've defined these things down here the way that I have, does it automatically update the struct, or do I still need to change something?
No, you're actually going to have to construct a struct with those fields inside of it.
Okay.
And the way you do that is very similar to how you define the struct, actually. So you just say the name of the struct, open curly braces, and then the fields. And actually, in this case, because you have, this is actually a shortcut. So the full definition of a struct, well, let's just go ahead and start writing it so you'll see what I'm talking about.
Okay.
So you can go down to your return value, actually.
Down here?
Yeah.
Okay.
So see, notice that we're still using a tuple.
Yeah, we don't,
still returning both the contents and your atom.
Right, but we just,
But you've really constrained or reduced the tuple.
Right, so I'm still returning the string, but I want to also do the struct. So does that go in this line? Like, would I do atom, open curly?
Yep. Yeah, and you see at the bottom, it's telling you the fields.
Oh, nice. So what I just...
So the full way that you construct a struct is that you say field name, value. But there's a shorthand where if the value that you're putting in is a variable with the same name as the field, you can just write the variable.
So I could just do charge.
Yeah, you can just say charge instead of charge : charge.
And then I could do the same thing where I do X, Y, Z.
Yep.
Okay. And then...
And close the curly, and that's it.
Okay. Nice.
Beautiful.
That's cool. Oh. And so like down here, if I wanted to print would I be able to print the struct or?
No.
Okay. All right. That's what I thought. Okay.
But hold on, we can fix that. All right. Go ahead and comment out your bond length for now.
Okay.
I forgot. In Emacs, if you visually select it.
Isn't it like alt comma or something?
Alt, I think it's semicolon.
Okay. You're right.
Yeah, why don't you go and give that a run? I think you're gonna get a compiler issue.
Well, yeah. Well, I mean, I already see this here.
Yeah, so right now I think it's mad because you're still trying to unpack it like a tuple.
Yeah. So I need to change that, right?
Yes.
Okay.
Now, another cool thing about structs is that you can actually unpack them just like a tuple.
Oh, okay.
So